This video is about adding and subtracting fractions with unlike denominators. The process in doing addition of fractions with unlike denominators, that means their denominators are not already the same, we have to, first of all, find a least common denominator. Then we have to build higher terms, and then we add or subtract as usual, and finally we simplify by reducing and or maybe changing to a mixed number. So we're going to practice this process. So if I have 3/7 and I want to add it to 2/5, you do not add 7 and 5. That doesn't happen. 7 plus 5 is not what we do. You do not add denominators. What we have to do instead is we need to find the least common denominator. Now 7 is a prime number and so is 5. So the least common denominator is just going to be the product of 7 and 5. Anytime, in fact, two numbers do not have a common factor, that means anything that's in common, even if they're not prime numbers, by the way, anytime they have nothing in common, the least common denominator will just be their product. But if they're two prime numbers, you know for sure that they will definitely be just the product of those numbers. So I'm going to be building each of these higher terms to 35ths. So now what we want to do is we want to go ahead and we want to proceed. So we have 7 times what equals 35? Well, of course, that would be 7 times 5. So what we did to the denominator, we do to the numerator. 3 times 5 is 15, and there's our new numerator. Now, moving on to the second fraction, 5 times what is 35? That would be 7. So what I did to the denominator, I also want to do to the numerator. 2 times 7 is 14. And now I have the higher terms for both 3/7 and for 2/5. So 3/7 is equal to 15/35, and 2/5 is equal to 14/35. And now we can proceed with adding two fractions. So when we add two fractions, when the denominators are like, we carry along this common denominator, and then we add the numerators, 15 plus 14. And that's going to give us 29/35. Now, as it turns out, 29 is a prime number, and it has nothing in common with 35, and therefore we know that we're finished with this problem right there. That's our final answer. Let's do it again. Now we have a little bit more complication in finding a least common denominator, so I'm going to do some prime factorization. 3 times 5 is 15. 12 is 2 times 6, which is 2 times 3. So we have 3 times 5 here for 15, and 2 squared times 3 for 12. So our least common denominator is going to have 2's, 3's, and 5's in it. So 2, 3, and 5. And our highest exponent of 2 is 2. Our highest exponent of 3, now this one can stump students a little bit. You see we have a 1 here and a 1 over here. And a lot of times students want to put both of those in there, but you have to make a choice. You only get one. So I'm going to just put one of those 3 to the first powers in, and then I get 5 to the first power. So what I have is 4 times 3, which is 12, and 12 times 5, which is 60. So I'm going to be building these higher terms to 60ths. So I'm going to have something 60ths plus something else 60ths. So in building my higher term, I'm going to ask myself, what times 15 is equal to 60? Well, if I don't know, I can look here. I have a 3 and I have a 5 already. Here's my 3 and my 5 here. So what I'm missing is 2 times 2, or 4. So 15 times 4 must be 60. So we do it again. 4 times 4 is 16. What you do to the denominator, you do to the numerator. All right, now we're going to go back and we're going to do this for the 12. So if we didn't know what times 12 was equal to 60, we can use this trick again. We have one of the 2's and we have, we have 2 2's and we have the 3. So what's missing is this 5 right here. So 12 times 5 is 60. And so now we do that same to the numerator, multiply it by 5, and 1 times 5 is going to give me 5. So there's our new numerator. And now we add them together. So we carry along our common denominator of 60, and we add our numerator, 16 plus 5, and 16 plus 5 gives us 21. And those are 60ths. Now you might go, oh, this one's odd and this one's even, and so there's nothing in common, but you'd be very, very wrong. Watch, look at the prime factorization here for 60. It's got 2's, 3's, and 5's in it, doesn't it? 2's, 3's, and 5's. And there are 2 2's, so you can write it as 2 squared there. Or probably what's more helpful for you is to actually write it out as 2 times 2 times 3 times 5, the long way. And then we have rewriting 21 as 3 times 7. And look what you see there, 3's in common. Another way to think about this is in terms of divisibility rules. They're not both even, so they're not divisible by 2. Would they be divisible by 3? Well, 3 would go into here because 6 plus 0 is 6, and 2 plus 1, divisible by 3, so that's divisible by 3. So you'd know that it was divisible by 3. So those divisibility rules that I talked about in the second division video, very, very important. Now we multiply back out. 1 times 7, which is 7, and then 2 times 2, which is 4, and 4 times 5, which is 20. Now remember that the other way that you could reduce that would be to recognize that these are both divisible by 3 and use the fundamental theorem of fractions to divide by 3 and divide by 3. And that would give you the exact same answer. Now moving along, 7/8 plus 3/4. Now in this particular instance, what we have is we have one number that is a factor of another, or a number that is a multiple of the lower one. And it is the bigger number that will be the least common denominator in this case. So anytime you have one number that is a multiple of another, or a number that is a factor of the other, then you're looking at the larger of the two numbers being your least common denominator. So in terms of prime factorization, 8 is equal to 2 cubed and 4 is equal to 2 squared. And to get the least common denominator, we say, okay, unique factors, which there are only 2's, right? And then highest exponent, which is 3. And so you see the least common denominator is indeed 8. And therefore, when we go to build the higher terms, we don't have any work to do for 7/8. 7/8 is already its higher term, so we don't do anything. We do still have to build the higher term for the 4ths term. So we ask ourselves, okay, what times 4 is equal to 8? 2 times 4, so then we'll do that same thing to the numerator, 2 times 3, and that's going to give us 6. And now we can go ahead and we can add these because we have the common denominators. So we'll go ahead and we'll copy that common denominator, and then we add our numerators, 7 plus 6. And so now we have 13/8. Well, 13/8 is an improper fraction, right? The numerator is bigger than the denominator. So we want to change that to a mixed number. So remember, changing to a mixed number, numerator divided by denominator. 8 will go into 13 one time. 8 times 1 is 8. 13 minus 8 is 5. So we have a remainder of 5. So this is going to give me 1, and the remainder goes in the numerator. The denominator is the original denominator, and there we go. That's our final answer. So that's adding fractions. Now for subtracting, you're just going to do the same thing. I haven't done any subtraction, but it's certainly the same thing. Now the last couple here, I have some mixed numbers. So the first thing I'm going to do is I'm going to go ahead and stack these like I've shown before. So 2 1/3, and I'm going to add to that 5, and a sixth. And then I see 3 is a factor of 6, or 6 is a multiple of 3. So I know that my least common denominator is going to be 6. So nothing happens to the 1/6. I'll just transfer it over here. And then I need to build the higher term for thirds to 6th. So I ask myself, 3 times what equals 6? Well, that's 3 times 2. So now I'll do the same thing to the numerator. 1 times 2, which is 2. And now I can go ahead and add these. So 1 plus 2, which is 3. And those are sixths, carrying along that common denominator. And now I'll go ahead and add the whole numbers, 2 plus 5, which is 7. But you see, I'm not done because this fraction needs to be reduced. It has a common factor of 3. So I'll go ahead and take out that common factor of 3. And now I have, don't forget the 7, and 3 divided by 3 is 1, and 6 divided by 3 is 2. So I have 7 and a half. And that's my final answer. All right, this one, a little bit trickier because it's bigger numbers. Why don't you give it a try? You try that one without any assistance from me. All right, hopefully you paused that and you did this one on your own. So if you stacked it up here, 1/34 and 3/4, so that we can add these together. Then what we want to do is we want to build the higher terms. Now 4 is a factor of 8, or looking at it another way, 8 is a multiple of 4. So we don't have to do anything with the eighths fraction again. We'll just copy it over. And we're going to build the higher term to eighths here with the fourths. So 2 times 4 is 8. So 2 times 3 gives my new numerator. Now we add together 7 plus 6, which is 13, and that's over the common denominator of 8. Ooh, but that's an improper fraction, so remember what we do is we change it to a mixed number. 8 will go into 13 one time with 5 left over, and that goes over the original denominator 8. And then we're going to take this 1 and we're going to carry it up here. So now we have 1 plus 1 plus 4, which is 6, and 8 plus 3, which is 11, carry the 1, 2 plus 1 plus 1, which is 4. And so now we have 416 and 5/8. And that's our final answer. Okay, now I have one more for you guys to try, a subtraction one. So this one is just very straightforward, no mixed numbers. Why don't you go ahead and try to do 27/35 subtract 8/21. Pause the video, try to do it, then come back and see if you did it correctly. Okay, here we go. 35 is 5 times 7. 21 is 3 times 7. So my least common denominator is going to have 3's, 5's, and 7's in it. So this is going to look like 35 times 3. So 35 times 3, 3 times 5 is equal to 15. Carry the 1, 3 times 3 is 9, plus 1 is 10. And so we have 105 as our least common denominator. So I'm going to go ahead and I'm going to build the higher terms. So 105 is my higher term, minus 105. And now I have to ask myself, what times 35 will give me 105? Well, remember, I don't have to work hard. Here's 35, so it gets multiplied by 3. So 3 times 27. So 3 times 7 is 21, so there's the 1, carry the 2. 6 plus 2, which is 8. Now here we go, 3 and 7, that's those two numbers, so what's missing is the 5. So times 5, so times 5. And 8 times 5 is 40. Remember that anytime you multiply an even number by 5, you're going to get a number that ends in 0. Now we subtract. 81